All right. Okay. Okay. So if we go back to our formula, I mean the notation, I probably should have put it here, but you have the notes in front of you, I think. At least I hope you do. We're starting out with $3,000, right? That's what we're investing. So P sub 0, our P sub 0 here is $3,000. Okay. And again, our R, right? That's our APR, 4% interest. This is 0.04. Now we're compounding quarterly. I think I said already, but I'll say it again just in case. When you're compounding quarterly, that means it's compounded 4 times each year, in a year. So N is 4 in this case. Now we want to know what's going to happen after 15 years. We want to know how much is in the account in 15 years. Okay, well, here's our formula. So this is our P0, $3,000, right? P0, that's the number in front. 1 plus R over N, 1 plus 0.04 over 4, raised to the N times T, 4 times 15. So we have to figure out what this is. If you don't have a calculator, you can definitely use, Desmos. When you put this in the calculator, you want to make sure you follow the, PEMDAS, I think it's called, the orders of operation. So basically, you want to make sure you calculate your exponent first. Or excuse me, you want to do you could do the sum first. You raise that to the exponent, which is 60. Then you multiply. If you ever plug it into the calculator and something doesn't make sense, don't be afraid to contact me. I'll help you. I can share a calculator through Blackboard if necessary, through the screen of it, that is. And also on Lumen Learning, you have calculators as well. Okay. But basically, this is what we have here. Right, so here again, I calculated this. That's in parentheses. Then I did the exponent. Then I do this raised to the exponent. That's what this number is. Now, I want to round to 2 decimal places. I'm using more than 2. I'm actually using 5. Okay? And so we multiply, we get this. So in 15 years, the amount in that account will be $5,450.10 in 15 years. So again, this is what would happen. Again, you could go through the calculation through Excel, like I did before. Let me see if I can get to it like this. But thanks to the formulas, we don't have to. Now, is there a way to get the total interest earned? Off the top of my head, I don't know if there's a formula. Not saying there isn't one. But if you wanted to, you would have to go through those calculations. All right, that's compounding. That's this example. Are there any questions about this? Remember, the chat I can't see. Although actually, no, I take that back. I could see it. Let me do this. Usually I can't see the chat. So if you have a question, you want to do the raise hand feature or speak into your mic. But I think everyone's okay. Beautiful. Good. Okay. Well, if there's no questions, let's keep on going then. Let's do another example. So now this one also, here's another one, right? Same idea. We have $10,000 in this case. We're investing that into an account. And again, it's paying 6% interest. It's being compounded monthly. So each month, they're calculating interest on how much is in there. I think this is actually how most savings accounts work. I know the one I have, I think this is what happens. The amount in there, I think it's every 30 days, it'll take a percentage of how much I have in there and add that on. So, So let's determine then how much will be in this account 2 years later. Okay, that's cool. So we invest $10,000. That's our initial amount, right? That's our principal. That's what our P0 is. The percent, you want to convert that to a decimal. That's what our R is. Now we're compounding monthly, once a month. So that means in a year, it's going to get compounded 12 times. So N is 12. And we want to know how much will be in the account 2 years later. So we take T to be 2. Here's our wonderful formula, as you can see. Okay. All right, so from here, right, again, when you're using a calculator, I would make sure you could put this into a calculator as I'm doing this so that you get the right answer. I was going to say, okay, we add this first, right? We're using PEMDAS, order of operations. Then we do the exponent, that's 24. Then we raise it to the exponent, okay? Then we multiply. The exponent part you want to deal with before you multiply. That comes first. And that's what I'm doing here. So in 2 years, we're going to have this amount, which is $11,271.60. Okay? And again, we're assuming also we're not taking money out or adding money to it. I mean, you could actually handle that, but I think you have to deal with differential equations. That's a totally different situation. Anyway, so we have this example. Here's a third one. Let's see. Are there any questions about this one? Okay, let's move on then. Here's a third one. Okay. Okay, so here first, notice first we're going to consider simple interest. I'm not sure why this is here. That should not be there. Let me fix that actually quickly. I copied the previous slide without thinking. Okay. All right. Anyway, wait. So we're doing a third example now. Okay. So here we're depositing, as you can see, $4,000, into a savings account. We want to know how much is going to be in there if 10 years later, if the account pays simple interest, 8% simple interest. Okay, so let's use our formulas, right? Notice this is simple interest. We're not compounding yet, although we will soon. So we have R, the APR, annual percent rate, is 0.08, right? We have T is 10, P naught to 4,000. So how much interest, since it's simple interest, right? The total interest here we can calculate easily, and we get $3,200. And then the amount after 10 years, right? It's the original, and then we add on the interest, and we get this. Remember, this is simple interest. Okay, I did throw in the calculations, even though it's not the full 10 years, but hopefully you can get the idea. I mean, after year 1, you start out with this amount, right? And again, the interest for the whole year is 8% of this, which is 320. You add that on, that's the ending balance. That becomes the new balance for year 2. The interest doesn't change because it's simple interest. So the ending balance here becomes this, and so on. I mean, this is not for the full 10 years. I only did the first 5. So, okay. All right. I just threw this in here. I thought it would help. I don't know everyone's math background, so I try to be cautious. But now here, we're going to suppose it compounds annually, as you can see. So, of course, a formula we're going to have to use. It's a little bit different. Okay, so here we have R is 0.08, N is 1, right? It's because, again, it's being compounded annually. That means once a year, our P sub 0 is the same. So the formula is going to, but the formula, of course, is different, as you can see. And when you do the calculation, you get this. And again, I went through the table just to illustrate what's actually happening, right? I mean, it's very similar, except what's going to, well, the idea at least, right? Year one is the same as before. 8% of this, you get 320. That becomes the new balance. But now you take 8% of this. So instead of using 320 again, we're going to recalculate the interest. We're going to compound, recalculate the interest. And so it's a bigger number. Add that on, becomes the new balance, recalculate the interest, and you keep on going. Then you add it on, this becomes the ending balance is what we have left out, is what's in there after year 3. That's the starting balance for year 4, and so on. Okay, let me stop the, okay, so we have this. Let me just pause the recording.